guy that I've finally put together. I've been slacking on. It's basically a high-powered work light, and over time I've been able to sort of confidently put together in my mind a good number of components to use here. Now in this case I've just sort of slapped together some stuff I had, which is a boost circuit, a buck circuit, and a 12.6 volt cell with the BMS board on there. So for one, you want to have a BMS board for your battery bank, and that's going to serve the simple purpose of, depending on which board you get, it might help balance charge those cells a little more, which is really what you want for just overall lifetime. You don't want one or two of your batteries to slowly die off for the rest. And it'll also provide some short circuit protection, and electronic short circuit protection. So if it was to get shorted out, then you can reset that simply by putting a charger to it. This particular boost circuit I found is a 150 watt circuit. It's good from 10 to 32 volts, and it'll boost from 12 to 35. Now it can handle about 16 amps max on the input, closer to 10 long term, but I don't need anywhere near that much. Maybe something close to 5, but that hardly ever is I'm usually driving it that much, hardly ever. What it just so happens to work out to where this 12.6 volt lithium bank, once it drops down to about 10 volts or so, then this circuit cuts off. It no longer drains and no longer operates. So I don't really need any fancy smanchy battery regulator or cutoff voltage here, because it just sort of works itself out naturally. Now those could drain a little lower than 10, but I mean, 3.3 volts or so, I'd say that's about normal for a low voltage indicator with those cells. The only reason I've got this buck circuit, which is an XL4005, good for 5 amps peak, is just for recharging. So I can actually set this to put anywhere from maybe 1 to 3 amps charge into the cells if I want to, which I've just got going to this little jack here, and that comes out. I've got a Schottky diode down in there to prevent the battery from backloading the buck driver. And then the only other addition here is I've got this fan, which literally just cut on right as I pointed at it through this little thermal switch. So the thermal switch is snugged up against the main LED heatsink, and obviously once it gets too hot, then the fan automatically shuts on. And I've noticed that does a pretty good job of mitigating that heat. It doesn't take long to cool it back down. This fan is obviously ran straight to the battery pack through the switch, through the thermal switch. So once that gets to a point where it's cooled down, I'll go ahead and cut the light down so it happens a little quicker. But then that'll automatically shut off on its own, which is a cool thing about it. So long story short, you've just got your 12.6 volt bank going through a booster circuit, which is running this roughly 30 volt LED load. Now this LED strip I have on here, those are going to max out about 32, 33 volts, and at which point they're going to pull probably close to 2 amps, 1.52 amps or so, which is really overdriving them. So basically what I did here, since this is not a current controlled boost driver, it's only variable voltage, I just threw a trimmer in series with this main pot that I'm using, and I've tuned that trimmer to the point where the output voltage, no matter what I set, essentially the highest setting I set the pot to now with that trimmer, it's not going to push these LEDs beyond a voltage where they consume more than about 1.5 amps. So that's basically how I did that. I'm just preventing it from ever drawing the maximum it wants to draw, and that gives me a range to where the lowest setting is about that right there, which looks pretty damn bright. It actually is fairly bright, but it's not crazy bright. It's a suitable low. So I'm not too worried about the lack of current control there, because this thing will more or less function within a good range from particular voltages, even if I leave it on for a super long amount of time. So that's basically how that works. And I've just got it in this, obviously this project enclosure. I'm gonna cover the LEDs eventually as well, but that's pretty much it. So as far as runtime, I mean, if I'm pushing maybe a couple amp, maybe 2.5 amps in here max, depending on the light output, you might get, I don't know, maybe an hour, a couple hours tops at your maximum brightness. Now, I could obviously add more cells in there. This thing's cut off now because it's cooled down. I could add more cells in there, but this worked out to be a pretty good deal to where, if I crank it around this level, it's going to last me a very long amount of time, and a lot of times you don't need more than that. But if you ever wanted to crank the insane light and get the really high output, then you're still good for maybe a couple hours or so. So I don't know, I thought that was a pretty good deal. So I've made a good number of these work lights in the past, and the main reason for that was because they're so easy to make as long as you have everything you need, which most people do. And the alternative commercial products are insanely expensive for you to get the good light output. Now, something like this doesn't output a whole crazy amount, but it's usually more than what I need. I was able to throw a flashlight beam on there too, so it's pretty handy for the size. But there's going to be a lot of situations where that light right there just simply isn't going to cut it. You need to illuminate a super wide area, maybe a large workspace, where that's when you need something like this. So you can see that sort of seems kind of bright until I cut this one on, and that just completely dwarfs it. So I mean, you're only going to get so much practical juice out of something like this until you really beef it up. Higher capacity, you have some type of way to mitigate the heat that's likely going to build up when you're pushing that many lumens. You have to have a more practical way to charge it, because USB charging at that point is not going to be really the way to go, because it's going to take forever. So a lot of little variables, but at the end of the day, something like this, it might not look all that great, but when you compare that to some of these other ones that you can buy, work lights that are close to $100 or more, I mean, Jesus, it doesn't even make sense. And now on the power supplies, we've got these leads hooked up to that little jack there, so it's not fully charged, still pulling about half an amp, but it's still got enough juice for me to show the brightness here. Alright, so still in the room here, lights are off. I cut that guy on, so just kind of aim it that way. On low, like I say, you can see everything you need to see. Just aim it at the ceiling. You can see everything I need to see in here, even though the phone might not show it too well. And now I'm going to turn it all the way up with it pointed at the ceiling. So I mean, this is putting out very equivalent light to these overhead LED strips I have up here that I've lazily just left that way over time. But this should be more than enough to light up an entire room, a fairly large room that you might be working in, or a whole area. So I'm pretty sure this is cranking out a little bit more light than some of the commercial ones you can buy, and I'd say a lot of those are probably putting out closer to something that right there, which isn't bad. And a lot of them are running from drill batteries and stuff like that. But if I can get more light, something like this, out of a smaller form factor and easily recharge it, I mean, whatever, it's a no-brainer to me.